Welcome to the Unit 8, Section 3 video on real-world applications using polynomials. Recall, the perimeter is the sum of lengths of the sides. When sides are represented by polynomials, simply add the polynomials and simplify. So the length of a rectangle is represented by 4a plus 3b, and its width is represented by 7a minus 2b. Write a polynomial for the perimeter of the rectangle. So it's helpful here to draw a figure. Here's a rectangle, and we have the length of 4a plus 3b and the width of 7a minus 2b. And if we're going to find the perimeter, we have to add the length of all the sides. So we are going to take 4a plus 3b, add it to 7a minus 2b, add it to 4a plus 3b for the bottom, and then finally 7a minus 2b for the other side. Now all that's left to do is collect our like terms and then combine them. And we end up with a perimeter of 22a plus 2b. Let's find the measure of the third side of the triangle. The perimeter is represented by 12x squared minus 7x plus 9. So in this case, we know that the sum of the three sides are going to equal the perimeter. So we set that up using L to represent the measure of the third side, which is what we'll be looking for. So we take our perimeter, set it equal to one side plus a second side plus L being our unknown side. Now we're going to take those two sides that we do know, and we'll take each of those trinomials and subtract them from each side, which when we move them to the other side, they become negative. Now we're going to take our first trinomial, which doesn't change. We're going to distribute the negative across the second trinomial, and we'll distribute the negative across the third trinomial. Now we will collect our like terms, and then finally combine our like terms, which gives us x squared minus x plus 5. So the measure of the third side is x squared minus x plus 5. Recall, the area of a rectangle is the length multiplied by the width. When the length and width are polynomials, multiply the polynomials to find the expression for area. So let's write a polynomial that represents the area of this rectangle. We are given that the width is 2x plus 1, and that the length is 3 times the width, 2x plus 1. So we're going to multiply the length and the width to find the area. So we do 3 times 2x plus 1 times 2x plus 1. Well, we can write 2x plus 1 times 2x plus 1 as 2x plus 1 quantity squared. Since we are squaring a sum, we can use that property to get 4x squared plus 4x plus 1. Square the first, combine your a and b terms and double it, and then square the last. And then we distribute the 3 across to find the area is 12x squared plus 12x plus 3. Let's find the measure of the area of the shaded region in simplest terms. So we have two rectangles. We have an outer rectangle and an inner rectangle. To find the area of the shaded region, we're going to subtract the measure of the area of the smaller rectangle from the measure of the area of the larger rectangle. So we're going to take 2a times the trinomial 5a squared plus 3a minus 2, which is our outer rectangle, and we're going to subtract the area of our smaller rectangle, 8 times the trinomial 3a squared minus 7a plus 1. Now let's distribute the 2a across the first trinomial, so we get 10a cubed plus 6a squared minus 4a. And let's distribute the negative 8 across the second trinomial. Negative 24a squared plus 56a minus 8. Now let's combine our like terms. And that gives us 10a cubed minus 18a squared plus 52a minus 8, which is the area of the shaded region. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.